All right, so it's 8:05. Anyone who's just joined, Adrienne just sent out the link and we'll get started. So what is SQL? This workshop is based on SQL, if you guys don't know. SQL works with relational databases, so it's basically used to retrieve and modify data. And so here is just some examples of relational database management systems. And SQL is really important and useful in data analytics. So yeah, we'll get into more about SQL and the kind of cool things you can do with it.
Right, so a little bit about the basics of what databases are. So databases are basically containers to store organized data. It could be like a file or a set of files. If you're thinking of like a physical real life database, maybe it would be a file cabinet. So the database can be classified based on its content. You might sort things by whether it's text, numeric, images, or you could use the organization system. So it could be a relational database, non-relational, distributed, object-oriented. So in SQL, we're going to be talking about relational databases. And DBMS is an abbreviation for database management software. This is used to create and manipulate the database. So relational databases are tables of rows and columns that are linked. One of the benefits of this is that it allows complicated queries. It's also pretty suitable for transactions, such as in sales. And you can reduce redundancy by linking things across tables instead of having the same row in a billion tables, or using specific SQL features that we'll discuss later when you're retrieving data. Some disadvantages, though, include that there is an increasing complexity with size, and it's less flexible than some non-relational databases.
Okay, so in SQL, we'll be mainly toying with tables. So each table is identified by a unique name. And typically what's stored is the data type, and how the data is named. So if you guys are familiar, there are columns and rows and tables. The columns tell certain attributes and the rows are kind of records. And so one thing that's really important in tables is that they have a primary key, and that's the column that identifies every row in a table. And basically what this primary key is, it's a unique row ID. So for example, like a kind of intuitive way you can understand is government ID for people, and government ID is used because it's unique and it identifies each person even people with the same names, and that's kind of same with primary keys. And it's really useful to identify certain rows. And so important thing about a primary key is that it must be unique and there can't be any null values. Just like for government IDs, you can't have a null value. And then it also cannot be modified or reused. So even if, let's say, someone is killed, no one, changes their government ID, it stays the same. And so that's how we use to identify objects.
That was a pretty harsh example. But yeah.
Yes,
right.
Yes.
We're going to move on to see an example of a table.
Right, so this is typical table that you might see in the real world. And so as you can see, a lot of guys are familiar with tables. You have the columns, which are the attributes. So over here we have customer ID, first name, last name, and age. And then you have your rows, which are the records. So each record is a certain canon. And so we have the primary key, and the primary key is the customer ID. And so notice that the primary key is not first name, last name. And this is because, there could be multiple canon guans. And so usually we use the primary key, which is a number, to kind of identify each record by itself. So 001 would equate to canon G, 002 Guanine Kin, and 003 Canon Guan. And of course, if you add more records, it'll just increment from there. Another important thing is that when you have multiple tables, you will probably work with foreign keys. And foreign puts the relational in relational database. And what foreign keys is that it provides a link between data in two tables. So it references a primary key, and what we said about primary keys is that it's a unique row ID. And so what foreign keys does is it help link data from one table to another. As you can see from the example, you can see that ticket purchase ID is a foreign key that's linked to purchase date ID under the dim date table, and etc. And foreign keys could also be primary key for that table. What's really important about foreign keys is that there is restrictions. So it cannot be null, and the key must be contained in the other table. So in this case, the customer ID has to be contained inside. The customer ID, has to have the same values as the SK customer ID under the customers table. And you guys can look into this more by yourselves. Foreign keys can also have duplicates. And this is just an example of how you could use keys to connect different data tables together and show the relationships.
Great. So now we're going to cover some of the basic statements in SQL. So SQL statements are not case sensitive, but the names of tables, columns, and values may be depending on the system. So you have to pay attention to the capitalization in certain systems. If you've ever used Java, you might be familiar with the idea that statements are separated by semicolons, and this also applies in SQL. Retrieved data is unformatted when you retrieve it, but you can sort it or something like that, and we'll show you how to do that later on. As common practice, we tend to go for uppercase keywords and lowercase column and table names. So that's assuming that the column and table name capitalization doesn't have to match. So if you're in a system where it's camel case and it has to be camel case, then make sure to take note of that. Also, the program will not take in white space as any sort of command. So you can just use it however you'd like to make it easier on yourself to read.
All right. So as you can see, here are just some basic statements in SQL. Knowing the green is the way you comment in SQL. But if you look at the black text, so what you usually do for SQL is you have select and from, and these are very important. These are the basic kind of words that you use. So when you want to select certain columns, you select and then put the column names. And then from a certain table, you do from table. You do not necessarily have to format this way in terms of capitalization, but this is just a better way in order for better readability. And so if you want to select all the columns, you could do the star symbol. And again, if you want no repeats, you could select distinct, and that would return all of the distinct values. And distinct applies to all of the columns. Again, building on top of those basic statements, sometimes you'd want to sort it. So in this case, let's say we want to sort it by the customer name and then by postal code. You could do select blah, blah, blah from the table, and then you can order by customer name and customer postal code. And so we want to order first by customer name, so we put that before, and then the postal code. And remember that the default is ascending, so if you want to get this descending, you do order by column descending. And remember, order by must be the last clause, so you can't put order by before you select. So there's another way you can toy with data, and it's with filtering. So let's say you want to find a customer postal code of a certain number or not a certain number. You can use the where statement. In this case, we're selecting the column customer postal code from the table customers, where customer postal code is not equal to 07727. And so the exclamation point equals sign basically means does not equal. And so this has to be right after the from statement, and it retrieves data that meets this requirement. So below is just other kind of conditionals that you could use if you guys are familiar with Boolean conditionals. Exactly that. So the exclamation point is just means not. And so you could do equal to, less than, or equal to, not less than, etc. Another thing to know is between and is null. Between and is if you want to look between two values from start and end. And then is null is if you want to find a null value. And lastly, just some basics and or not. So in these statements, you can filter using and or for multiple conditions. The first case, when you use and, we're retrieving data that must meet both conditions. So in this case, we'd want customers that both fulfill the requirement that they don't have the postal code 07727 and that they're in the city, New Brunswick. In the second statement, we're retrieving data that must meet at least one condition. So we're asking for all of the columns, all of the customers that either have a customer postal code that is not equal to 07727 or that live in city equals New Brunswick. And the last one is just another way you can write does not equal, and you could use where not. So in this case, we're selecting all of the customers where not customer postal code equals 07727, and it's the same way as putting the exclamation point with the equal sign.
All right, so now let's get into join. So the first one up is inner join, but you can also drop the inner and just write it as join. This may depend on the system, but it's really, some systems it's optional, some systems you might have to specify inner join. I don't know all the systems, but the one we'll be using in a bit at least allows only join. So basically what this does is that it's similar to, if you know anything about sets or even just drawing Venn diagrams, you can see over here that it's the area that overlaps between two tables. So now we're using two tables in one statement. So if you want to specify which column you're getting, you have to do the table name dot the column name. So here we have tickets dot ticket purchase ID. You can see now we have merch dot merch purchase date. And we're going from tickets inner join merge. So you can kind of think of it as, just for understanding's sake, as if you had parentheses around here and around here. So around tickets, inner join merge, selecting from the combined table. And this is the join condition. So you want to find cases here where a customer purchased a ticket and also purchased merchandise. Okay, now we're looking at outer joins. So once again, like with inner join, you can drop the word outer. So you could just write it as left join, right join, full join. So a left join is going to include all the records from the left table. And a right join is, of course, going to include all the records from the right table. But since the order that you write the tables in is up to you, you could just swap the orders of the tables and never use a right join in your entire life. A full outer join is going to be a combination of the left and right join, so all records are included from both tables. These joins are potentially going to produce null values. Say you're selecting one column from one table and another column from another table. You may not have a matchup between all of the values, and we'll see an example of that later on. Okay, last one up is a self join. So this is kind of like duplicating a table and then joining it together. Now we're using the same table here, so we obviously can't just use table name dot column name. Instead, we have to give an alias, like a nickname, to the table. So here we have A and B as our nicknames, and we do A dot column name, B dot column name. In this case, you do not need to use the join keyword, but if you want, you also can, and we'll show an example of that in a bit. And here you can see the where condition A field equals B field. So it kind of looks like if you were just doing a regular selection, but since there's no join, but you're actually having the table appear twice. And this can be used to compare records in a table to each other. And once again, we'll see an example of that later on. It's kind of a weird thing to wrap your head around, but hopefully it'll be clearer once we do the demo. And speaking of the demo, it is in fact demo time. So give me a moment to switch my screen. Let's see. And I see Alec has dropped the link in the chat to the thing we're going to be using for our demo. So if you want to follow along on your own, you can also use that, but I'll have it shared. So you don't actually have to open up the link if you don't want to, or if you're on a phone or something and you can't. Okay, can everyone see this? All right. Thank you for actually replying, because otherwise I was going to be like, I'll just assume no answer is a yes. All right, so first let's take a look at the customers table. How about? And does anyone remember what the command is to select all the columns from the customer table? The asterisk is correct. So we're going to go select. All right, and let's run it. So you can see over here that I did not put the semicolon. We're only putting one statement, so we don't actually need it on this particular editor. And this is everything in the customer table. There are 91 records you can see. We have a customer ID, a customer name, the contact name. So maybe the contact name in this case is something like the name you'd call who owns like a phone number or something. You can see here the customer name and the contact name are different. Who knows exactly what they've done there? And now what if we want to see only the customers from a specific country? I don't know, any of these countries. We could go with France, maybe. Does anyone remember how we do that? Any idea what the keyword is? Yep, that is correct. So we're going to be using where, which is fitting in this case because we're talking about countries, but even if we were talking about something else, it would still be where. So France. All right, and now you can see all of these customers are living in France. Some of these are actually not people, as you can tell. These are probably like businesses or something. I don't know what victual means. My French teachers are regretting everything. All right, so let's take a look at these results. What if we wanted to sort them based on, how about the postal code? Does anyone remember the command to put them in a specific order? I'll give you a hint. I gave you more than half of it if you're counting by the number of characters when I just said that. Right. So yep, it's order by. That is correct. So order by postal code. And we'll go with, we'll just run it like this first. So as you can see, these are ascending values. Although if you wanted, it's automatically ascending, but if you want, you can also add the ascending keyword there, just to remind yourself maybe. And if we want it to be in reverse order from this, does anyone remember the keyword? Close. There is the C, yeah. And there we have it. All right, let's switch gears a little and work with a different table. So we're going to view everything in products, and on this particular demo, because they're trying to make it easy for you, you can actually click here and it'll automatically run this select statement for you. And this is everything in products. So you can see that products has a product ID, which is its primary key. And it also has a supplier ID and a category ID. So does anyone remember what these are called? They're keys that are the primary key of another table. Can you change your name? That's great. Yes, these are foreign keys. All right. We're going to officially change your name everywhere now, and that's just what it's going to be. So these are the foreign keys in the supplier table and the categories table, respectively. And they're used as identification there. So you can see that you do have duplicates here because you can have multiple products that come from the same supplier or multiple products that are in the same category. So what if we want to do some filtering, right? So instead of just doing where equals like before, what if we want all the products that are from suppliers 1 through 3? So all the way up to here. Can I highlight on here? Yes. All of these. How might we do that? Well, we already had the where from before, right? And what are we looking at here? It's supplier ID. So in this case, supplier ID can be 1, 2, or 3. So there's a few ways we can write this. You can do less than or equal to 3. To Scout. Or you can go for less than 4. These are whole numbers, so those are going to be equivalent. Or you can go for the long way and supplier ID equals 1 or supplier ID 2. And you can see we have the same results. So as you can see over here, we can have multiple conditional statements in the where clause, and we're connecting them with ors here. So it's kind of like if you know other coding languages, it's like if you use this. And instead of using an or, we can also use an and if we want to have all of our results meet 2 requirements. So let's do something that we know is possible based on this. Let's see. So where the supplier IDs are 1 here, and you can possibly have a category ID of 1 or 2. So let's go for a category ID of 1, I guess. That should give us 2 records. Oh, I didn't type anything. Okay. I was looking at it like, why? All right. Yeah, so there we go. And what if we want to sort by price? So what if we want all the products that are less than $20 and all of the ones that are greater than 50? So as long as it's less than 20 or greater than 50, we want to include it in price. Any idea? All right, so here we can use less than and greater than. Why do I keep typing the wrong one? Price is less than 20. I think that's what I said. All right, so we're not going to be inclusive here. 20 or 50 doesn't count. Let's just run this. And make it easier on ourselves. We can sort by the price. All right. So now we can see the cutoff here. So all of these are less than 20, and all of these are greater than 50. And we have our wonderful, really expensive wine here. All right, and we just saw that wine price. So here's something that we haven't covered in the PowerPoint. What if we want to take maximum value? So we want to know what is the most expensive thing in the products. So let's take product ID, product name. Let's see, min of price. Okay. From products, and we don't need this anymore. And I said max, but I wrote min. That's all right. So once again, we can see that expensive alcoholic beverage, a really high price. I don't know if that's per bottle. I don't remember what was the packaging thing that was there, but also you can note here that I capitalized these wrong, but it still worked. So that tells us that this particular editor is not case sensitive. Oh, like, I don't know what that means. All right, so we can look at some, oh, okay. Okay, so we can also look at some other functions. So we can take a look. One of them is called count. Count everything from products. Find everything that's in category 2, for example. Some didn't capitalize this right. So there are 12 things that are in category 2 in this table. And another thing you can use is average. So a sensible thing to average would be price. And you can see over here that we just had this labeled as count, which isn't really helpful. So we could use an alias here and give it another name. So in this case, we want to call this average price. Although honestly, this wouldn't be too misleading if this was just the column title. But we're selecting once again from products, and we don't need this part anymore. And this is the average price of everything in that table. And if we can do average, of course, we can also do sum, considering that you kind of combine count and sum to get average. And go with this. Oh, okay. I still call the average price. Well, that's definitely misleading. But here we go, sum price. Or I could call it total price, but whatever. So there we go. That's the sum of all the things in products. So if we wanted to buy one, however big the package size is of every single thing in products, that's how much it would cost us. I don't know if that's in US dollars. I guess it is. But maybe you might have guessed from the fact that we have all of these functions, but you can also directly do some arithmetic operations on the values. So once again, looking at price, what if we wanted to buy more than one of something? So We want the product name of the thing we're buying. Price. So just the price of one is going to be called unit price. I'll go with camel case to match. In case anyone doesn't know what camel case is, not familiar with coding, it's just when you capitalize the first thing. Actually, I think it might be if you start with lowercase letters and then just capitalize the first word under the next word, but it's something along those lines. And let's say we want to buy 5. Okay, that wasn't times. Down products again. And this gives us, so you can pick an easy one. 10 times 5 is 50. Check that it's correct. And once again, we can combine things. So we could do something like and this is the next price again. So this just gives us that really expensive line once again. If you wanted to buy 5 units of it, whatever the units are, it would cost you that much. All right, and now let's take a look at all the products again. So let's say we want to find a part of a string. So this one has sauce. Maybe we want to find everything that has the word sauce in it. So all the sauces. So let's see, we can take, we'll get rid of these packets because I've just been leaving them there. And where product name. And the keyword here is going to be like. You can format it like this. Gosh, if I can type correctly. All right, and we see we have 2 options here. There's Northwoods cranberry sauce and Louisiana Fury hot pepper sauce. So they both have the word sauce right in there. And you can see that they didn't check the capitalization. So it was all right here that we had it lowercase. You can also use underscore. So maybe we want the second letter here to be O. What are they here? We don't need it to be, yeah, to let it have other stuff behind it. All right, there we go. All right, so this is everything where the second letter is O. So you can see Northwoods, kombu, tofu, all of these. Long life tofu. And if we wanted to be the third letter instead, let's see if there's any of these that exist. We can just add another underscore there. So now there are 2 underscores. And you can see now the O is in the 3rd spot. So there's other wildcards. We're not going to go through all of them, but this is just a, oh yeah, underscore means a single character. A single character, we don't really care what it is. It's just represents like a placeholder. Just you can see that there are 2 underscores there. Does that make sense? Yeah, okay, great. All right. And do you guys remember back when we were selecting those suppliers, how we had supplier ID. Oh, actually, we were still picking products, right? Not suppliers. But we were looking at the supplier ID and we wanted it to be 1, 2, or 3. Well, there's actually an easier way to do that than having a bunch of OR statements. So we could do in 1, 2. So as long as the supplier ID falls in within one of the options here, then it's going to be returned. And this doesn't really matter with 1, 2, and 3 because they're consecutive, but maybe we want to go for something like 10 here. I hope that there is a supplier ID 10. Yes, there is, okay. And in that case, it's really useful. And these don't have to be numbers either. So we could go with product name. And tofu. What else? I can't remember. Chez is right there. Man, sorry for my horrible typing skills. I'll just copy and paste this one. Aniseed syrup. All right. Okay, correctly. Yes. Okay. So these 3 are returned. And you can include something that's not in there. So you can see there's no match for this one. Oh, I'm sorry. It should be the new spelling. All right. And yeah. And now we have another thing that was fairly brushed upon in the PowerPoint, as in we kind of had it as a footnote. Does anyone remember? If you want to do a range of values for price that like from 20 to 30 or something like that. What we might use, it is in fact a word or 2 words, I guess. So right if you don't. So all it was between and 20, 30 here. So this gives us everything within that range. And you can see there's a 30 here. This is inclusive. All right, next up, let's go into joins. So we've been seeing all these category IDs here, but we don't actually know what they mean. Like 2 means nothing to us. And none of these numbers really mean anything. So what if we wanted to retrieve the category name from category, right? Yeah, it's called category name. So let's see. Select. So let's do p dot product name p dot category ID c dot category. Okay, so here I'm doing P for products, C for categories. But the editor isn't going to know that unless I do this products as and we're using a join. So if you recall before, you don't need to write the inner categories as see on this for here actually on my gosh All right. Equals C dot. And I put a minus sign instead of an equals. Oh, that's correct. Yeah, okay. So now we can see we have all these category names here. And we're talking about the inner join. If you want, you can actually write inner here, but you can see that it's black instead of, like, the other keywords are green, are just green, almost blue. The other keywords are all blue. So it won't give you an error, but you don't have to include it. It's just a reminder to yourself in this particular editor. So if we want to take some other joins, take maybe a left join, right? Get everything from one particular table. So I did say before that we were going to show you an example with null values. So category ID. And basically the way we get this if we didn't have a matchup. So if we did something weird, like you can see over here, these don't have a match. I mean, they shouldn't. It's kind of a weird thing that we just did. But these all have null values. Now, if we wanted something a little bit more proper, can anyone tell me what the query would be to return all the products with suppliers? So what's the overlapping key between suppliers and products? I do have it here already. So it's supplier ID. So if we go s dot supplier ID and suppliers as s dot, we can guess that they have something called supplier name. Yes, okay, cool. Good guess on my part, I guess. Yeah, so that's a proper way to use this. Now you can also do self joins. So I'm just going to copy and paste this because it's longer and I don't want to torture you with watching me type it out incorrectly. So this is a weird use sometimes, but you might want to find all the customers that are in the same city, but are not the same customer. So here, right, this is the same as if we did, gosh, it's like not equal, basically is what this is. But if you want an easy way to remember it, it's like it has to be less than and greater than at the same time, which isn't possible. And this gives you all the different combinations of matching customers that are within the same city. So you can see this person matches with this person and that person, and also this person. And also, I promised I'd show you how you can do this with a join. I didn't actually have to delete all that, but whatever. So you can also use join here. All right, And a little bit fancier now. So let's take a look at order details. Now we can use a new command that we haven't discussed before called group by. So this is used if we want to find maybe all of the total number of orders placed by a customer. We're going to tell the editor to group all of the orders by one customer together. So I'm going to do select. What do we need? Customer. I meant to click on orders before. Sorry. Okay, so we're looking at this. Now we have customer ID. So we need the customer ID to know what we're looking at. And we want to count. I lowercase that, whatever. Okay, look at me. Totally screwing up this capitalization. All right, from orders. And once again, the phrase here is group by. We're going to group by customer ID. So all the same customer ID things are going to be grouped together. And let's sort this for simplicity's sake when we're looking at it. All right. So the person with customer ID 20 has 10 orders, and you can see these are sorted. All right. Now, once again, looking at orders. Customers. What if we wanted to find the total number of customers inside of a certain country? Any ideas? So we're going to be using group by again. So you have to use count as well. So what are we counting this time? We're counting the customers. So count customer ID. Yep, that's correct. And what else? We need the country, obviously, because that's what we're looking for. From customers is the table once again. And this time we're grouping by the country. So everything of the same country is going to be grouped together for the count. Order by this again. We'll go ascending this time. Don't need a keyword. All right, and I should reverse this order just to make it easier, because that bothers me. Here we go. Next is us with 13. All right, now what if we want to filter and use group by? So instead of where, we're going to use the word having. So we can put it over here. So what if we only want countries that have less than 10 customers? You can scroll down and see all the countries that had more than 10 are gone. All right. Any idea if we wanted to change this up? Find countries with Well, let's pick a different question, actually, something a little bit more. What if we wanted to find, are there any overlapping cities? Yes. What if we wanted to find the number of customers in each city? Any ideas? So I'll give you the previous code to look at. Right, so we're really just going to change this to city. City. We don't need this having thing anymore. Actually, we can just leave it there and comment it out. And have that. All right, I think that works. Yep. Lots of different cities in the world, so plenty of them only have one customer. But London has a lot of people. All right. Well, that's pretty much it. Does anyone have any particular questions? If not, still hang around because we have our group photo. So if anyone's able to turn on their camera, please do.